Connection between what the equation looks like for parallel lines and what an equation looks like for perpendicular lines. So that's what we're going to be focusing on today. So we're going to do a couple of examples to prove how this works. What I'd like for you to do is glue your graph kind of in this area of the paper. So leave a couple lines in all this space here on the left, and then glue the graph right there on the right. So the first thing I'm going to do is give you an equation in standard form.
Wait, so we glue one on the right side or two on the right?
Just one. Yep. When the equation is given in standard form, the first thing you have to do is change it into slope-intercept so that you can graph it. Remember, when you have it in slope-intercept, you have it with the slope and the y-intercept, and that's really easy to graph. So just like you guys practiced yesterday, you would subtract the x's to the right side. And then you would get y by itself by dividing by 4. And then you would take that equation and you would graph it by plotting the y-intercept and using the slope to plot a few more points. I think only 3 will fit on this graph, so I would start at 0, 3. And then I would have to go down 3, forward 4. And because I can't continue over here, I would go up 3 and back 4. And that would be the line for my first equation. And my slope here is -3/4. Right, so that's something you want to pay close attention to because we are talking about the connection of the slopes and how that creates either parallel or perpendicular lines. Are you getting all this down, Ben?
Yeah, I have it all written down.
Mm-hmm. Let's not make a mess with those candies.
I'm not. There's literally no mess.
So the other equation I would give you might already be in slope-intercept form. So all you have to do is graph it. Excuse me, this should be -2. So I would be down here at -2. And when I graph them and when I plot them, I can see very clearly that they are parallel. And hopefully what you noticed on your own is that their slopes are the same. Which is pretty easy for us to observe the identifying parallel slopes is pretty easy. They should match, right? If two lines are changing vertically and horizontally at the same rate, then they of course will never intersect.
Oh, that's
Okay.
impossible.
You're so funny.
Dude.
So then on the next page, we'll do another example to show what it looks like for perpendicular lines. Same thing, just kind of put your paper, like your graph over here to the right a little bit. Leave the space. Go ahead and glue it there.
That's right.
Again, we have an equation given to us in standard form. So we're going to change it to slope-intercept so it's easy to graph. And then I'll take that slope-intercept form, I'll plot my y-intercept again, and I'll use my slope, -5 over 2. I was able to get 4 points there because I could go up and backward to stay with the line. And my slope here is -5 over 2. Again, that's something we're going to pay close attention to. If I give you the equation already in slope-intercept form and I plot it, I would be at -1, and I would go up 2, forward 5. Or down 2 and back 5. And when I crisscross those, you will see that where they intersect makes a right angle. I've heard a couple of you say she's going too fast. The only reason I'm going fast is because if I slow down, you guys start talking. And it takes me 8 minutes to get you back on task. So I'm just going to keep moving until you prove to me that if I go slow, you won't just erupt in conversation.
No, I like this. Please keep on going faster,
Okay, so what do you notice about the perpendicular lines? What do you see happened between this slope and that slope? Carson. It's a reciprocal and
It's a negative.
it's an opposite. Okay? So perpendicular lines opposite, meaning if it's positive, it's now negative. If it's negative, it's now positive. Reciprocal means it flips. Okay? It's -5 over 2x. Sebastian, please stop. Okay, so we're not going to graph any more of these, but we are going to practice by looking at two linear equations, and you're going to tell me, would these two lines be parallel, perpendicular, or neither if you graphed them? Okay? Parallel, perpendicular, or neither. Why would they be parallel?
Because they have
The same
same
slopes.
but different
Yep.
intercepts.
Yeah. What's the fractions
Same slope, parallel. Okay?
So would it still be parallel if it was y equals 3x minus 5 and y equals 3x minus 5? Would that still be parallel?
Those would actually be infinite because it's the same line. Yeah, so.
Perpendicular.
Is it?
Nope, that's
No, it's not
parallel.
because it's not one of them has to be
That's
negative.
Yeah.
parallel.
Taking a guess. It's not.
That's
Yep.
parallel.
Please don't guess out loud.
So it's not there.
But wouldn't 1 over 3 be the opposite of 3 over 1?
Yeah, but that's.
Well, that's the reciprocal, but the opposite is the positive and negative, right? So we have a reciprocal because this would be 3 over 1, but we have to have both of those things to be considered perpendicular. Carson? Yep. Opposite and reciprocal. And the last one. Mason? They are perpendicular. What is the y-intercept of both of these? 0, right? So one of them is then increasing 4 over 1. One of them is decreasing 1 over 4, so that's going to make a perpendicular line. So these are opposite and reciprocal. Griffin? It's just 0. Yep. If they don't put anything here, then that's your signal. It's 0. It's at the origin, right in the middle. Okay? Good question. Keep this out. Don't put this away. We're going to start the practice together. You do need more lined paper. Start with 1 page. Did you pass out candy? Well, everything's a whole costume. What's your favorite? Keep. Impressive. Creepy and impressive. Okay, well that's hard to be upset about. How many lines are we doing? Just start with 1.
One or two more.
Let's take a look at this. Voice is off. I would like to get started on this before you guys leave today. Everybody sit down. Okay, this is going to take a minute for you guys to kind of understand what's being asked. If you have a highlighter, take out a highlighter. And we're going to highlight some important details for each question. Pass that down, please. Thank you. Okay, on this paper, everybody listen. Sebastian, please stop. Stop. Sebastian, stop. Just stop making noises. Okay. On this paper, what you're going to be doing is you're going to be given information where you have a point. Okay? Cohen, I don't want to have to explain this twice. Thank you. You're going to be given a point, and your job is to write slope-intercept form, write in the given form they want it. So for this one, my answer is going to be in slope-intercept form because it specifically says write a linear equation in slope-intercept form. This one, my answer is going to be in standard form. Because you guys have already practiced, please stop with that noise. Going back and forth between the three forms, right? So your job is to take whatever's information given and rewrite an equation in this form that is either parallel or perpendicular. I will tell you the number one mistake last year on this paper was students didn't pay attention to what they were trying to create, a parallel or perpendicular line. So we're going to do a couple of these together. But right now I want you to highlight where it says parallel or perpendicular. I don't want that to be what causes you to have mistakes. Okay, the reason that's so important is because when you are converting, you will always be given the slope of the line that you are going to be creating it, either parallel or perpendicular. So if it says parallel, your slope should be what? Exactly the same. If it says perpendicular, your slope should be opposite reciprocal. Okay, so let's do question 1 together. Our answer is going to be in slope-intercept form. Y equals mx plus b. We have a point and we have the slope. So what am I going to use to put it into slope-intercept form? Again, I have a point and I have the slope. What am I going to use? Point slope. So that is y minus y1 equals m times the quantity x minus x1. So I'm going to go ahead and put, don't forget to label x1 and y1, that will help you. So I'm going to put these into point slope form. Y minus 2 equals, and my slope is parallel, so it's going to be the exact same as the one that I'm given. 3/5 times the quantity x minus 5. Yes? We're getting there. So we can't get to slope-intercept form until we use point slope. Like, we don't know what the y-intercept is, so we can't just use that. So we have to kind of go through a different, direction, take a different route. So you're right. So now I have it in point slope form, but I need my answer in slope-intercept. So I'm going to change this into slope-intercept. Y minus 2 equals 3/5 x minus 3, right? 3/5 of 5 is 3,
Yep.
right? You could always use your calculator, or you could do where you multiply the numerators. 3 times 5 is 15, divided by 5 gives me the 3. And then I add the 2 to both sides. Now I have y equals 3/5 x minus 1. And that is a linear equation that would go through this point and is parallel to this line. And that would be my answer to number 1. So there's a couple things. This is very similar to what we did, yes, you guys did for e-learning. The added layer is you have to create a line that's parallel or perpendicular. So this right here is going to be a really important part of the equation that's given to you. Let's go down here to number 4. Because this one's, they want it in standard form and perpendicular, so they are different than what we just did. I'm just going to put number 4 right here on my paper. So remember, standard form is ax plus by equals c. A can't be 0, a can't be negative, a cannot be a fraction. Okay, so I have a point, I have a slope. What is my slope going to be of my new line? What's it going to be if I want it to be perpendicular? -2, right? So again, I'm going to start out with point slope form. Y minus y1 equals m times the quantity x minus x1. I'm going to take this point in this slope. I know it's going to be -2 because -2 is the slope of a perpendicular line. Y minus 0 equals -2 times the quantity x minus 2. Y minus 0 is 0. Y equals -2x plus 4. So this is great. It's in slope-intercept form. What does my answer need to be in? Standard form. So how am I going to move this into standard form? Vincent? I'm going to add 2x to both sides. Luckily that works. I have 2x plus y equals 4. I don't have to do anything to this because this is positive and it's not a fraction. If it asks for an answer in point slope form, then you would have just stopped right here. You don't even have to distribute anything because this is point slope form, right? So you guys have about 6 minutes. I think you probably get 1 or 2 more of these done. It is not homework. I just want you to do the best you can. Pay really close attention to how they want it and if it's parallel or perpendicular. I don't want any talking. If it becomes chaos in here, this will be homework.
Marsha, why are you already done with the entire page?
Nate, mind your own business. That's creating chaos. Just work. Thank you.